So I give about 150 speeches every year, and I'm very excited and happy to give a speech. This time I'm so happy, but very, very, very nervous. I'm more nervous than you were, Antti. So please forgive me if I collapse or something. So this is my first speech about quantum technologies. I'm not a technologist myself. I'm an educationalist. And I know very little about technology. I couldn't code anything. I have coded something in year 2004 when I coded my first website. And I can tell you it was very ugly. It was really horrible. You wouldn't like to see it. But anyway, I'm a paranoid optimist, but I'm also a paranoid learner, because I feel that if I'm not learning something new, I feel that I'm missing something, or something is passing by and I don't see it. So I came into artificial intelligence and robotics in 2011 when we wrote a book, Boho Business, with adjunct professor Jari Kaivooja, and I saw that these two technologies were very important because they were going to impact not only businesses but also the entire universe, of course. So it became my task to promote and teach about this. Well, not teach, but maybe inform about these technologies and their impact. So I have been doing that, for example, in European Commission and different committees there. And well, it's a good place where you can also leave a mark about your stuff. So quantum technologies are now in some committee considerations because I was there to talk about it. What else? Well, I have been working with several ministries, and yeah, I will go to my presentation now. So anyway, how did I come to quantum computing? It was about my paranoid learning. I saw the robotics in 2010 or something like that it's going to emerge. Something is going on. There are breakthroughs almost every day, and a fantastic presentation by Mikko. And I have been following Mikko, and I was so happy when you became the professor, because I was like, yay, we have a quantum professor in Finland. And so I saw that this is coming, and there is definitely something bubbling there, and I wanted to learn more. But there is not much learning opportunities for those who are not technological people. So I needed to find something, and I found an MIT online program. And so I was in an airport heading towards Brussels once again, and Antti was there. We met at the airport. And our mutual friend Ilona Lundström was there, and I said to Ilona, because I was so excited about the MIT program, that I said to Ilona, do you know what I'm going to have this course in MIT about quantum computing. And Ilona said, well, Antti is here and he's going to the same program. I thought, okay, if Antti Vasara is taking this program, it's probably much beyond my level, and I thought that I will never survive it. Somehow I survived it, and I'm so proud not only that I made it and I got my little online diploma, but Antti promised that anytime you need help, thank you Antti, just call me, I will help you. And I had to ask for Antti's help only once, because there was a task, and I was staring at that thing at least for 3 days, and I didn't understand a blip what was there. So I said, Antti, please, I don't understand what this is. And he said, I don't have time to think about it, but the right answer is B. Okay, thanks. Thanks, Antti, it was B. Anyway, so I think my task here is to think about what could we do with this computer. And if you think, and you said weird, and I've been thinking many times, it's weird. And I kind of feel good because Richard Feynman also said that it's weird. And if somebody says that, okay, I understand this computing, so you are a weird person. Anyway, Richard Feynman, he was also a weird person. He was a very good bongo drummer, and he was an artist and a poet and whatever he was. So he was a crazy person also, but he was crazy enough to understand that this is important, and he needed to take it forward. during the MIT program, I was watching a bunch of YouTube videos, and I found a video where there was a guy who said that the world in the future will need only about 2 or 3 of these quantum computers. And it reminded me of IBM, because in the 60s, everybody know this, Tom Watson, the CEO of IBM, then when the computers were the size of this room, he said that we will need only about 5 of these computers in the future. And now they are saying we will need only 3 of these quantum computers in the future. It probably means that we are going to need more quantum computers than classical computers in the future. I don't know, but somehow it's just struck me. So what is the thing here? Why is it so important? Why is it so important that I hope that Mikko and your team and your colleagues around the world, that you can make this development faster than we think now? Because we have such complex problems to solve. And we cannot do it only with the classical computers. We need the computational power of quantum computers. So we are entering a new era of innovation, not only because we are entering, because the era is there and we need to enter it so that we can solve those problems, so that we can make this earth livable for us and create new businesses. So I think here again comes the weird word imagination. We need to imagine what could we do to save this world? What could we do to make better business? And then the imagination comes in, and then we try to find the technology to solve that business. I'm a great believer in technology, that we can do lots of things with the help of technology. So here is something I wanted to show you. What do we actually know about this system where here we have biosphere, here we have the society and the economy? When we think about, for example, now we have the climate change crisis. So we talk about this. And then we think about we need economical growth. So we talk about this. Then we talk about inclusion. So we talk about this. But we don't actually have the understanding of the entire process. What is going on here? So that if we do something here, something happens here. If we do something here, so something happens in the entire process. And this is something that we need to focus on more in the future. And this is a very complex system. It is said that the human brain gets lost when the problem has more than 7 different aspects or parts. And we need to see we want to see it, okay, so now we have climate change, let's have less plastics. But that's only a part of the problem. Of course we need to clean our mess, but we need to find solutions that combine this entire system. And what about data? Now we have fantastic sensors that we could send out to the world, to deep seas, to the space, to the Siberian tundras and everywhere, just to send us data. But the human brain does nothing with that data. And that data is so huge that soon the classical computer cannot do anything with data either. So we need something that can make the computational part for us. So what about this?
If everything is known, what happens then?
What happens then? Good question. I don't know. Anyway, so what is there? Do you know what is that device there? Who knows? Do you know? It's something that makes things happening. It says, what about human being? But that is not a human being. That is a nano-sized robot. That robot could travel, for example, inside our veins and clean our veins from inside. It could go in any part of our body, perhaps make a surgical operation somewhere if there is a tumor or something like that. It could bring medicine there, but it can also, again, collect the data. And I'm saying, why I'm showing this robot, I love that little guy, because I'm sure it can help us humans to live better lives, more healthy, and make, for example, surgical operations less invasive. So what I'm here saying is that what we know about this entirety is just a nanoparticle of everything what there is. We know a lot about the human being, but not much. But then comes the part, what you said, what then, when we know everything? What shall we do? And thanks to, and already now, quantum computers, they are making simulations and optimizations. This is already possible, but in the future, even more so. When we cannot, we know the data and we say, okay, we should do this. But before we start doing anything here or inside the human body, we must simulate that complex data, put it in the simulation to show what is the best optimal solution that doesn't harm anything further. There was this. So here, a little bit more about complexity. So here you can see that what is going on, internet to genomics and drones, and what is happening here, circular economy, logistics, and everything what is going on. And if there is a radical disruptive innovation, we can have this kind of line upwards, or we can find a new economic solution here. But here you can see that there are, when we start to put together these lines and connect with those problems, here we can have demographics. We can have fertility that is decreasing, less Finnish people at least in the world, and we can have the climate change and everything. And these problems, to find these solutions, this is why I want that we can have these exponential technologies to put these things together to find the optimal solution. I love this picture by Tata Consulting. His name is Frank Diana. He has lots of good ideas. I think this is something that we could consider when we when we are thinking about the solution to the entire universe. So Antti was mentioning that we need a national program, and there are several national programs already. And the EU has the Quantum Flagship program, which of course is fantastic, but in Europe we will never have that money to compete with China or US with the power of this quantum computing, but we can have a national program, and we should start with the strategic intent. What is this country intending to do, and which kind of impact is this country going to provide with the help of a quantum computing? So in Trump's government, they have already made this initiative, and it's becoming a law. So there is a law that has to do, and here is Christopher Monroe, who was a part of this group developing this program, Quantum Initiative in the US. In India, they have made a very, very, very good, I would say, very good strategic plan for quantum computing, and they are intending to become one of the quantum powers in the world in India. So I hope that we can start after this seminar as soon as possible building this quantum computing program for Finland. Spooky action at the distance. There were several things that I found that is really, really spooky. And for example, here, what I was thinking about, and I forgot to say because I'm so nervous, is that I've heard something about artificial atoms. And we can really recreate the world, re-engineer it, not only to clean our mess, but with the help of synthetic biology, quantum computing, artificial atoms, we can fabricate novel atomic structures. And that is something which is really weird. But, well, it is weird. So here, spooky action at the distance. I didn't understand. I still, Mikko, I can't understand how is it possible. But when I've been reading lots of books, so they are always bringing up the European robin, this bird. The bird knows exactly when it needs to move from north to south. And they are saying it's because of the magnetic fields. We humans, we cannot feel those magnetic fields, but this bird can. And there is a guy, I read his book too, Jim Al-Khalil. And let's say what Jim Al-Khalil has to say.
This is the European robin. Every year she migrates from northern Europe to the tip of Spain and back. In this laboratory in the woods, biologist Henrik Moritzen is trying to solve the mystery of how she does it. Henrik's investigating a long-standing theory that robins navigate by the Earth's magnetic field. His laboratory is an ingenious magnetic bird cage, and these plastic cones lined with scratch-sensitive paper provide the key measurements. Henrik's artificial magnetic field is like the Earth's, except that he can point it in any direction he likes. Inside their cones, the robins always respond to the field, leaving scratches in a single direction. The big mystery is how. The Earth's magnetic field is incredibly weak, far too weak for any living creature to detect. But Henrik has found an intriguing clue by giving the quantum robin a mask.
And you have then a hole in front of one eye or a hole in front of the other eye. But what we can see is that if you cover up the right eye, you turn off the magnetic compass processing in the left part of the brain. If you cover up this eye, you turn the compass off in this part of the brain.
Light must be causing chemical reactions in the robin's eyes. In fact, it's the power supply for a unique form of magnetic compass. Inside her cells. In recent years, extremely delicate experiments have shown that subatomic particles really are entangled. It means they can subtly and instantaneously influence each other across space. It seems the same thing is going on inside the robin's eye.
When a photon enters the robin's eye, it creates what's called an entangled pair of electrons. Here's how it works. Each electron has two possible states. For simplicity, I'm choosing to call them red and green. Now, here's the weird thing. Until I measure it, it's neither one nor the other, but both at the same time.
In quantum entanglement, the electrons are mysteriously linked. For example, if I get red on the first, I always get red on the second. It's not a game of chance anymore. It's as if the first electron is telling the second one what to do.
The electrons seem to know that they should both have the same color, no matter how far apart they are.
The really important part is that the two electrons needn't be the same color. They can be entangled in a different way, so that if the first electron is red, the second one is always green. It seems that this mysterious connection is the ultimate secret of the quantum robin's compass, because the direction of the Earth's magnetic field can influence the outcome.
Near the equator, they may be more likely to be red-red, but near the pole, they may be more likely to be red-green.
Tiny variations in the Earth's magnetic field change the way electrons in the robin's eye are entangled. And that's just enough to trigger her compass.
After this, okay, so you didn't see Jim Al-Khalil's explanation about quantum entanglement, but please go and have a look at the video in YouTube, because it's a very nice video explaining this very, very weird phenomena of entanglement. So this is a slide I have been ending my presentation since 2013, and it has been robots make wealth, people create value, and now I added quantum will save the universe, and we need to save the universe, and therefore, Mikko, I really, really wish all the luck to your work, and I will be following your work and tweeting about your work so that we can spark up the quantum computing world. Thank you so much.
Thank you, Cristina.
Thank you.